Hey guys, I'm just going to be doing a quick video of long division of polynomials. So we're just going to start out with the first example on the worksheet. And we're going to start by just finding what factors this has with this. So clearly the 7s, nothing needs to happen there. The only thing that's different about these two is really the x squareds and the x to the 4th. So we can see here that we only need an x squared up here, because if we multiply the x squared by the 7x squared y, the 7 stays the same. The x squareds combine together, because remember we always have to add exponents, so it becomes x to the 4th, and then because there's nothing to combine with the y, it just becomes y. And then we subtract these, we get 0, and now we're going to add 21x cubed y, and now we need to figure out how many times this can go into this. So obviously 21 divided by 7 is just 3. X cubed divided by x squared is just x, because remember when we divide we subtract the exponents, and y divided by y is just 1. And then when we subtract these, so let's first multiply these together. So we have 3 times 7, which is 21, x times x squared, which is x cubed, and 1 times y, which is y. So when we subtract them, we get 0. Now we add the 42x squared y. 7 goes into 42 6 times. X squared divided by x squared is 1, and y divided by y is just 1. So let's rewrite this at the bottom. So we have x squared plus 3x plus 6, and we're multiplying this by our divider, which is 7x squared y, and this is our final answer. So now we're going to move on to something a little bit more complicated, because obviously there's a binomial here. So 2 terms makes it a little harder, but it's still very simple. So 3 divided by 1, because there's an imaginary coefficient of 1 on the x, is 3. And x cubed divided by x is x squared. And because remember we subtract the exponents with division. So now here's where things get a little bit more complicated. What we do is we multiply this 3x squared to the x and the 3. So when we multiply them, we get 3 times 1 is 3, and x squared times x is x cubed. And now we're going to multiply the 3 to this 3. So we're going to add 9, because 3 times 3 is 9, and then there's an imaginary coefficient of 1 here. So we're going to multiply the x squared by the 1, which is going to give us x squared. So now we're going to subtract this whole binomial, and we get 0x cubed plus 8x squared, right? So now this is good. And now we need to focus about this 8x squared. So if we look at it, we can see that 8 divided by 1 is just 8, and then x squared divided by x is just x. So now we have an 8x up here, which now has to go to both of these terms as well. So if we multiply the 8x by x, we get 8x squared, and if we multiply the 8x by 3, we get plus 24x. Now we're going to carry down this 27x, and now we can subtract the terms. So 27x minus 24x is going to give us 3x, and now we can bring down this 9, which is going to give us plus 9. So that means that we only have one more term to cover, and because 3x divided by x is just 3, we're going to add a 3 on at the end, and 3 times x plus 3, we're first going to start with the 3 times x, which is 3x, and 3 times 3 is 9, so we're going to add a 9, and when we subtract these binomials, we get a remainder of 0, which works out, and so our final answer is 3x squared plus 8x plus 3 times x plus 3. So there you go, that's your final answer. Now we're going to try the same example with synthetic division, which I think is a lot easier personally. So what we're first going to do when we start our synthetic division is we're going to set x plus 3 equal to 0, and we're going to solve for what x is when it's equal to 0. So x is negative 3, so that's what we're going to put on the outside of this synthetic division. So synthetic division setup is a little different than long division setup. So instead of putting these whole things in here, we're just going to put the coefficients. So the coefficient of 3x cubed is just 3. The coefficient of 17x squared is just 17. The coefficient of 27x is just 27. And the coefficient of 9, and then we're assuming that there's a ones place here, is just 9. So now what we start by doing with synthetic division is we carry the 3 down. So we're going to start by just saying 3 down here. And we multiply these two together. So 3 times negative 3 is negative 9. And now the weird thing about synthetic division is that we're actually going to add these together. So negative 9 plus 17 is 8. And now we multiply these together. So now we have negative 24. And we add these together, we get 3, which multiplies by the negative 3 to get negative 9. We add these together, we get 0. Now, let's just go through a few of the terms for what each of these things mean and in terms of places. So this last term is always going to be the remainder. So you always want that to be 0 if you're trying to get a perfect factor. This term is going to be your first ones digit. So this is ones, and then it just goes up by a coefficient of x each time. So we do x, and then this one becomes x squared. So looking at this, we know we have 3x squared plus 8x plus 3, because this is still in the ones, and we can multiply that by, and we have to make sure that we look up here to our original, which is x plus 3. And as you can see, this is the same as our last slide right here, showing that these provide the same results. However, clearly synthetic division is much faster and easier. So we're just going to do one more example for this. The key thing to remember about synthetic division is that you have to have each place represented. So for example, this jumps from x cubed to x, so that means we need an x squared in there. So when we rewrite it, we're going to rewrite it as 24x cubed plus 0x squared plus 10x minus 8. And this 0x squared doesn't change the equation at all, but it just adds an extra layer in there so that we can keep going and don't get stuck without that extra x squared there. So the first thing that we always do is we solve for 0. So we're going to do 4x minus 2 equals 0. We're going to have 4x equals 2, which means that x equals 1/2. So the 1/2 is what's going to go on the outside of the synthetic division, and remember our setup here. And now each coefficient needs to go in one place, right? So we have 24 for the x cubed. Now we need to make sure to put the 0 in as well. And then we have 10, and then negative 8. And just a reminder of what we're looking for, this place is going to end up being our remainder. This is going to end up being our ones place. This is going to end up being our x, and this is going to end up being our x squared. Okay, so now let's get started with the synthetic division. So the 24 carries down to become 24. If we multiply that by 1/2, we get 12. We add 12 and 0, we get 12 again. 12 times 1/2 is going to be 6. 10 plus 6 is 16. 16 times 1/2 is 8. And negative 8 plus 8 is 0. So this is good because we get 0 as the remainder. And now we can rewrite this as 24x squared plus 12x plus 16 times x minus 1/2. However, as we can see, this is not what we got in the original equation. In the original equation, we had a 4x minus 2. So that means that there's going to be some factor in here that we're going to need to pull out. So luckily for us, I'm just going to erase some of this at top. Luckily for us, the 24, 12, and 16 all have a common factor of 4. So I'm just going to rewrite up here. We're going to pull out a 4 from each of the factors. So we have 4 times 6x squared plus 3x plus 4 times x minus 1/2. And now we're going to distribute the 4 into this x minus 1/2, which makes it 4x minus 2, which is the same as above. So now we can rewrite some of this, and we can say that this final answer is 4x minus 2 times 6x squared plus 3x plus 4. So there you have it. There's our final answer. Obviously that one was a little harder, but that's also a good reminder that we always need to put in an extra place if we don't have a certain term, and also that we need to make sure that we're ending up with our original value. Okay, now we're going to work with finding terms. So for example, we have this extra variable k in here. So what happens when we know that there's a certain remainder, and finding the value of k to make sure that this fits perfectly into here. So we're just going to start by setting up our synthetic division. So first we know that x minus 3 equals 0, which means that x is going to equal 3. So we're going to put a 3 on the outside here, and then we're going to start writing out all of our terms. So our first coefficient is 3. Our next coefficient is negative k. Our third coefficient is 26. And our last one is negative 6. Okay, so this is going to be the remainder slot. And we already know that this is going to have to equal 0. This is our ones place, this is our x, and this is our x squared. So we bring down the 3. We multiply these together, we get 9. Now here's where it gets a little complicated. Once we add the k and the 9, we're going to keep it and just say 9 minus k. And now we're going to multiply this each time. So 3 times 9 is 27, and then distribute the 3 to the negative k, minus 3k. And now when we add these together, we're going to get 53 minus 3k. And now we're going to multiply through again, and we get 159 minus 9k. And we're going to add these together. And now we know that this added together is going to have to equal 0, because that's our remainder, right? So if we solve for this equation, we get 159 minus 9k minus 6 equals 0, which simplifies to negative 9k plus 153 equals 0, which goes to 153 equals 9k, and k equals 17. So that gives us our constant k in the equation, and that means that this becomes 3x squared minus, because there still is minus here, minus 17k, or minus 17x squared plus 26x minus 6. So we're just going to do one more example of that. However, this time our remainder is negative 13, so that's a little bit different. So we're going to start by solving for x as always. X plus 4 equals 0. X equals negative 4. So we put the negative 4 on the outside. And now we're just going to start by writing out all of our slots. So this is going to be the remainder slot. This is going to be the ones. This is going to be the x, and this is going to be the x squared. And now we do know that our remainder is negative 13, right? We remember that. So we know that the negative 13 has to go in this remainder slot. So we know that whatever this portion ends up being, that's going to have to end up being the negative 13. So we're going to start by writing out all of our terms. So the coefficient of 3x squared is 3, and then 7, and then negative k, because remember we always have to look at the coefficient on the term, and then 15. So we bring down the 3, we get 3, multiply these together, we get negative 12, add these together, we get negative 5, multiply these together, we get 20. Now remember, we add these together, and then we do 20 minus k, and then we multiply these together, and we get negative 80 plus 4k. However, remember that these, when these add together, this needs to equal negative 13. So we're just going to solve for that. I'm just going to erase a little bit of this up top. So if this has to equal negative 13, we know that 15 minus 80 plus 4k equals negative 13. And just for the sake of time, I'm just going to simplify that for us. And we get to 4k equals 52. And then divide by 4, we get k equals 13, which means that this goes up to the top and plugs in for that negative k. So our final value becomes 3x cubed plus 7x squared minus 13x plus 15. And then we have divided by x plus 4. And that's going to give us a certain terms, which I think becomes 3x squared minus 5x. And then we have, I think it's plus 7 with a remainder of negative 13. So really all that we need to do in this is find k. So we found it and we're good. So I hope that makes a little bit more sense with synthetic division and long division. Good luck, guys.